All right, here are the practice problems that I just sent you by email. And I'm going to do the first one, the proof by induction, and as a video, and we'll see how it goes. So here is the problem we're trying to solve. Is the sum from as k goes from 0 to n of r raised to the k, and this is a sum that we've used several times in class. We think that it will sum up to r to the n plus 1 minus 1 all over r minus 1. So let's give it a shot. First thing that I'm going to do is my base case. And I'll specify that this is the base case where n equals 0. Then I'll just write down the left-hand side, substituting in 0 for n, the sum as k goes from 0 to 0 of r to the k. That is equal to just one term, where k equals 0, so that is just r to the 0. Anything to the 0th power equals 1. I'll now write down the right-hand side, and again substituting in 0 for n, so we have r to the 0 plus 1 minus 1 all over r minus 1, and here r to the 0 plus 1 is just r to the first, which is just equal to r, so here we have r minus 1 over r minus 1, and that equals 1. 1 equals 1 most of the time, so check. Next, we'll just write down our assumption. We're going to assume that it's true for n. And I'm, again, just writing down the equation here. So we get to assume that what we're trying to prove is true for at least one value, which is what we proved at the top in the base case. So that's the relation of the base case to the assumption. So since it's true for at least one case, assuming that it's true for that one case, is it true for the next one? Then we've proved number 2, then we go on to number 3, number 4, number 5. So that is providing a template that then you walk on all the way down to all of the natural numbers. So there's my assumption. So assuming that it's true for n, we need to prove that it's true for n plus 1. So prove that the sum that k goes from 0 to n plus 1 of r to the k is equal to r to the n plus 2, that was n plus 1 plus 1, minus 1 all over r minus 1. Well, the first thing I want to do, because it's the one trick that we have for inductive proofs, is I want to construct this so I can substitute in this. I need to be able to use my assumption. So here I've got almost that, but I've got it going up to k plus 1. So I just need to pop off the n plus 1 term. So we have the sum k equals 0 to n of r to the k plus that n plus 1 term, which is just r to the n plus 1. And again, this I'm going to put in my question marks. I'm wondering, or I need to prove that these two things are equal. So I'm going to leave the right-hand side alone and simply work on the left-hand side. At this point, I can use my assumption. I can just substitute in all of this for that. And just a matter of writing this down, r to the n plus 1 minus 1 over r minus 1, and plus this term, r to the n plus 1. And that's the thing we want to make sure. So we're just working on, we're going to keep massaging this side until it's the same as that side. Well, the first thing I need to do, I'm adding something. I need to get it over a common denominator. So I'm going to do that at this point. I'm just writing down this stuff. N plus 1 minus 1 plus r minus 1 times r to the n plus 1. That will all be over r minus 1. And now it's just a matter of multiplying out. So again, I'm just going to write down this stuff over here. N plus 1 minus 1 plus, and then multiply these two terms together. We have r times r to the n plus 1. That's going to be equal to r to the n plus 2. And negative 1 times r to the n plus 1 is negative r to the n plus 1. And all of that is over to r minus 1. Now I'm getting really hopeful at this point because I've got an r to the n plus 2 term sitting here and I want 1. I've got a minus 1 sitting there and I want a minus 1. And what do I have left besides the thing that I want is a positive r to the n plus 1 and a negative r to the n plus 1. And thankfully those just vanish. So we're going to just combine like terms. We have positive 1 r to the n plus 1 minus r to the n minus 1. And so those turn into 0. We have a minus 1 and a plus r to the n plus 2 over r minus 1. And all we need to do now is flip these two. R to the n plus 2 minus 1 over r minus 1. And we've shown that we can keep massaging the left-hand side till it is exactly equal to the right-hand side. So we've earned our check mark, Q, E, D. Thank you.